I've ordered an Elegoo penguin bot, which was quite difficult to get hold of at the moment. But while I was looking for that, I also saw this very cheap biped robot advertised on eBay, so I thought I'd get one of those to investigate. And I was particularly intrigued because it uses a microbit controller that I haven't used before. I've only ever used Arduinos. And this was something the BBC developed to give out to schools in about 2016, I think it was. And it's got some quite interesting features. We'll look at that in a minute. Anyway, so I thought that, and it's potentially much easier to program. You can program it using sort of blocks of commands rather than a C programming language, which is just impenetrable for most people. So it arrived in this very unremarkable looking brown box with some Chinese writing on it. Somewhere it's got a CE sticker, whether that's genuine or the China export, as they call it, their own version of the CE logo. And obviously the bits aren't in here because I've made it last night. But I'll just show you, the first thing that greets you is this wonderful Chinese packing list, so that gets you a bit worried about what you're going to find. There's lots of plastic bags full of bits, which are quite well organised, to be fair. A bag with all the acrylic sheet bits in it. Another bag with some stepper motors, another bag with the electronics. And then I got a bit worried because I didn't think it had come with the micro bit. I thought you might have to buy this separately, which would make it obviously much more expensive. But I did eventually find the micro bit in an anti-static bag. And there was another anti-static bag with the control of the main board in it, which I'll talk about a bit later. Comes with quite a nice double-ended screwdriver. You can turn it around so it's a flat or a cross head. A rather strange remote control that looks like it's off of some cheap car audio unit or something. It says car something on the bottom. Car MP3. So presumably you can use that in some way to control the robot. Some rubber feet that go on the bottom that I haven't stuck on. And a massive bag of screws. And I knew it didn't come with any batteries. Now this is one problem with this device, is it uses this 18650 lithium battery, and they're quite expensive. They seem to be used a lot in vaping machines. This was the only way I could find to buy one singly, was on Amazon for about $8.99. Mostly they come in quite big packs because obviously if people are vaping they get through them like anything. Anyway, that arrived and it came in quite a nice little plastic tube. It said it was Samsung, but it isn't actually, it's just a generic thing. What else have we got in this box? Well, we've got a DVD, which is obviously one that someone's burned themselves. And right at the bottom of the box, it does have an instruction manual in English, which is amazing. Well, mainly in English. Some bits are in Chinese, like the diagram. So I thought, well, the first thing to do is check all the bits are here. So it's got a list of parts there. Yeah, they were okay. And then screws. I thought there's far more screws than this. I'll count all the screws. So I did that. Then when I started to build it last night, I realised that isn't the complete screw list. That's only for stage 1 of the construction. And the construction's quite nicely broken down into different stages. So you've got stage 1 is assembling the feet. And it all goes together quite nicely. You have to be a bit careful with these bits that they don't snap. One was weakened a bit because the nut was in slightly the wrong place. Basically the nut goes through from the underneath. So it tells you about doing the feet and surveys on the feet. That stage is pretty simple. The next stage, which is doing the bottom of these plates, it seems to only describe some of the sections in detail. As you can see, it's got a list of the screws for that stage as well. I did find, because it didn't say what screws you had to use for a lot of things, I tended to use the shortest screws that looked so they fit, and then I ended up in trouble with these last two things I had to mount with these two circuit boards, which go onto short pillars, and I do use all my short screws up, so the long ones I had left were going to hit each other coming up from the bottom and down from the top on those, so I had to pinch some from somewhere else. But I mean, they do supply plenty of screws. There's quite a bag of leftover screws and things when you're finished. A few of those are because I haven't put them all in, because I might be taking it apart to give to someone. Except I think it might end up too complicated. So there are places I haven't put all the screws in yet. So then you've done the second board with the 2 more motors on it. Then finally you do the top bit. Get to the end of the instructions. Then it talks about the electronics. Now it only describes where some of the things connect to. It describes where the servos connect to. As you can see, it's all a bit messy. There's 4 servos which go into 4 places on this board. There's the infrared module, and then there's a sound module. Don't quite know what all these things do yet, and they all plug in. Now it's this kitten board which takes the battery. The micro bit will fit in that slot there. Then it's got lots of these pins. So unlike the Elegoo kits, where generally the boards are specifically designed for that kit, so you can't plug things in the wrong places, this has massive scope for plugging things in wrongly. But this board looks quite good, and to be honest, for what I paid for the whole thing, which was about £30, the micro bit seems to retail for about £15, and this breakout board seems to be about £15. So the rest of it, I'm saying, you basically get for free. Yeah. So the other things about this board here is it's got 4 LEDs along the front. I did manage to download an instruction manual for a very similar looking board here. And that does describe how to use it and what it does, which is good, because the instructions basically, when you get to the electronics bit, it tells you where to plug things in, but then doesn't explain anything else at all. So that's a major flaw. For example, to charge the battery, you have to press this button when you insert a new battery to reset the battery charging circuit. And it doesn't describe that at all in the manual for this. So I've just had it on charge, and I'm going to try it out in a minute. Oh, the other thing is this funny remote control. That needs a battery as well. It takes a CR2025 button cell in there, so I'll have to find one of those somewhere. And then, yeah, it's very vague on what facilities it's got, whether you can control it with a mobile phone, because the board here has got, the microbit has got Bluetooth support on it, so potentially it could be controlled by a mobile phone. Anyway, I'm going to fire it up and see what happens. Firstly though, a little bit more about the microbit. So I've always used Arduinos before in the last couple of 2 or 3 years while I've been doing this sort of stuff. I've been doing programming for a lot longer, using other weird bits of hardware, but then I discovered the Arduinos. So this is a what you can probably call the standard Arduino, the Uno, which has got rows of pins top and bottom. And this is the Nano, a reduced size version, which does much the same thing. And here's the microbit for comparison. So it's slightly smaller than the Uno, but bigger than the Nano. Computer power wise, it's a rather more powerful, got more memory, better processor, because it's a much more modern device than the Uno that's been around for quite a long time. However, to make the Uno do anything sensible, you need to add things to it. The only built-in components for end users are really the one LED, which you can make flash. Wow! And there's a serial port which you could use for things. But the microbit's got a lot more built in. So as I said before, it's got Bluetooth communications built in. It's also got an accelerometer and a compass. On the other side, it's got an array of 25 LEDs that you can use as sort of rudimentary display, and it's also got two user buttons, A and B. Then along the bottom here you can see it's got a list of line of contacts, and these are quite clever because it breaks out the power and then three other lines onto these ring things, which it reckons you can clip a crocodile or a grip on, which is a bit dodgy. But interesting, they'll also take a 4mm banana plug as well, which is quite handy. But if you want to use the myriad of other pins on that edge connector, you really need to put it into something, some sort of expansion board like that. Whereas the Uno has rows of pins and the Nano has solder pads that you can put pins on. So a bit of a different concept. I also checked out the DVD, and it has some videos of constructing it and some more instruction sheets, but unfortunately they're all in Chinese. They didn't really mean very much. I'm sure they're very good if you can understand the most popular language in the world. So I'm going to turn it on now, and I haven't turned it on at all before, so goodness knows what's going to happen. I found a battery for that funny remote control. Oh, something happened. Its feet moved and some lights have come on when it's doing something on its display. Hello. A, left. Oh, look, it's doing its instructions on the screen. That's quite clever. So if I press button A, oh, B, right. It's got a sort of built-in tutorial. S-H-A-K-E. Shake. Chase the dot. What does that mean? Don't know what it wants me to do now. I don't know what it's trying to do. Try pressing some buttons on the remote control. Try pressing all the buttons on the remote control. Nothing happens. Ooh. If I wave my hand in front of there, the light comes on. 1, 2, 1, 2. Check, check, check. Well, it's obviously wanting me to do something, but I don't know what. So it turns out that wasn't some clever demonstration code they put on the robot. It's just the standard microbit demonstration program, which has nothing to do with the robot at all. So I then went back to the code on the DVD, which is all in Chinese, or partly in Chinese. And if you load these onto the robot, they do actually work and make it do different things. I wrote down what the different programs do. So number 0 calibrates the servos, which is described in the sloth robot documentation. The screen says Cali, and then a dot lights up. You can select this between the four corners using the A or B buttons, and then press A and B together to select that as the survey to work on, and these correspond to the 4 servos on the robot. Having pressed A and B together, you then press A or B to adjust that survey until it's level, so the robot is standing in a straight line. Then you press A and B again, and the display will show that blob on the screen and then a number which you need to write down for that servo. You repeat that 4 times and get 4 numbers, and then in the code you can enter those 4 numbers in the calibration offsets box, which is in the startup routine, and this makes sure the robot's all level. So I've got my 4 numbers written down here from the 4 blobs in the corners, which correspond to the first, second, third and fourth row down on here. I've then just set up different things for the different actions for the different buttons on the remote control. There's walking forward and backwards, turning left and right, moonwalking left and right, shaking left and right, up and down, swing, large swing, walking boldly or walking shyly. And I've allocated those to buttons on the remote control. Finally, for button number 2, I've allocated this command, which is stand still, to turn false arrows to 90 degrees, which means it should be in a straight line again. So here's the robot. Let's try and make it do some things. So I'll make it walk forward. I've just got it doing the action once at the moment for each of the commands. If you look on these commands, the second box after that's the action, which is this Chinese, and it says how many times it does it, so I've got 1 for everything, and that's the speed it does it, which I've got 50 for each of them, which is half the top speed, I think. So that's walking forward. We've got walking backwards. Before I did the calibration, it used to fall over and get tangled up and whack things into each other, so that's obviously quite an important step. That's turning left. That's turning right. What else have I got? I've got moonwalking left, moonwalking right. I've got up and down, where he does that. Walking boldly, and walking boldly backwards, which makes him fall over. Sometimes if you press the stand still, it helps to sort him out. So we can try walking boldly backwards, and he doesn't fall over. Walking shyly. Walking shyly backwards. Which other ones haven't I done? Swing. There's a big swing somewhere. That's big swing. Oh, there's shake left and right. Have I done those? Anyway, so it does work. Whoops. I suppose it falls over. There's also other commands related to the different sensors. So in the sloth one, there are commands to do with the sound activation, which is on this chip here, which I think I've got disconnected at the moment. And then we've got infrared or ultrasonic avoidance detection. For the ultrasonic, you use this sonar to get the values, and I'm not sure about the infrared at the moment. I haven't really played with those yet, but I'm sure they're fine. So in the editor, things do work with, if you just load one of their programs and alter it, you have to cope with all this Chinese everywhere. So some of the extensions they've got here, these are called extensions, the ones that aren't the standard functions, and you have to add them in. cbit_ir is available on GitHub, and that makes the remote control work. That seems to be in English anyway, so we don't have too much trouble with that. That just initializes the remote control and then has a block for making commands. The make robot extension has lower level commands to do with just moving the servos by set amount, so you'd have to program a whole sequence to make it do one of those movements, which are just available off the shelf in Sloth. And the nearest equivalent extension I can find to make robot, if you go in and load an extension in here, is something called robot bit. Now I've got both his legs working, but only on a sort of very crude basis. If you want the sloth one but you don't want it in Chinese, you're a bit stuck, because there's a sloth one you can download in extensions. If you type sloth in there, it'll find something. So you can see now everything's turned into English, but there's a problem with using the English version in that only one of the legs works. The other custom extensions you've got here are the NeoPixel, which is for the row of LEDs along the front of the robot. There's a row of 4 RGB LEDs, they're the white things. That is the standard NeoPixel extension. Sonar is the standard sonar one for ultrasonic, and that's about it. So to summarise, you're basically getting a biped robot for the cost of the microbit and the robot bit expansion board. But the instructions aren't too bad as far as assembly, but they don't tell you how to use it. The DVD's full of lots of non-English files. If you use their Chinese extensions, it will work as intended. But if you want to use the walk actions pre-programmed, you can't use the standard sloth extension, which has the same name as theirs because only one leg works. And if you use the robot bit extension, you've only got low-level control, so you'd have to program complex sequences to make it do the walking actions. So in conclusion, it's all there, but it's not quite all there, if you get what I mean, in terms of being ready out of the box. So you need definitely quite a lot of fiddling to make things work properly. Thanks for watching.